It's 7, correct? Okay, so example 7. American astronauts working on a space station on the moon toss a ball into the air. I thought if they were on the moon, there was no gravity, so it would just float around.
Yeah. No, there's low gravity. There's not no gravity on it.
But it's not going to follow the same laws of physics that it would on the Earth. Anyway, that's totally beside the point. All right, the height of the ball is represented by the equation F of t equals, and they give us that equation. Let me write that one down. Let's see, negative 2.7 t squared plus 13.5 t plus 14. All right, where t represents time in seconds since the ball was thrown, and F of t represents the height of the ball. This was something I was explaining to somebody the other day. Get in the habit, our points are normally x, y's. Get in that habit of, with regards to this problem, what is x and what is y? X is always whatever the variable is here. So in this problem, x is t, and it says y is f of t, but it says in that problem it's the height of the ball. Okay, so the x is the time, the y is the height. So just get used to that part. Alright, so to the nearest hundredth of a second, after how much time does the ball hit the ground? So you got Mr. Astronaut here. Yay, Mr. Astronaut. Standing on the moon. Got craters everywhere. Alright, so he's on the moon. Whoops, he's got a big helmet around his head. Alright, so he's got his spacesuit on. Alright, so he throws a ball in the air. We'll say it's a baseball. Throws a ball in the air, comes down, hits the moon. Okay? So, here's our y-axis, here's our x-axis. How high was he when he threw the ball? 14 what? 14 feet. Did it say that in the problem? Didn't say it, but it's in the equation, right? No, I mean, does that make sense? He's 14 feet tall? No, not really, but. All right, so 14 feet. So that point right there is 0, 14, right? Just labeling those key points. We got our maximum right here, whatever that is. And then we got where it hits the moon down here. We don't know that one yet. All right, so it says, to the nearest hundredth of a second, after how much time does the ball hit the ground? So is that a maximum? Is that an intercept? Is that a value? What is that? It's a maximum. Read. Put your Chromebook up. Or whatever you got out. It's an intercept. It's right here, right? Alright, so when we go to our calculator and we type this in, maybe. Alright, so we've got negative 2.7. Oops, not that. Negative 2.7 x squared plus 13.5x plus 14. And I'm just going to go zoom 6 just to get us to that standard window. Don't know if that's going to help me or not. Now I want to see more of it. Now we're talking about real world problems. So do we really need to see negative x's or negative y's? No, so we want to go ahead and change that on our window to like whatever, -1, -2, something like that. But we need to see more of the y maximum, right? Okay, so we're going to go in our window, because this is where a lot of you are having problems. Again, let's change that x max to like -1 or 2, whatever. X max, we didn't say anything about. Y minimum, let's change it to -2 since we did the other one. And we know we need to increase our y max. And we're at 10. Doubling it, think that would work? Okay, so we'll double it. Let's go by 20s. Get a graph, see how that helps us. Still can't see it. So we doubled it, so you want to double it again? 40 or 50 or whatever. So let's just say 50 just to be on the safe side, see if that helps us. So let's go to 50, but now let's don't count by 1s. Let's count by 2s or something. The larger you get, if you increase your maximum, always increase your scale. Oh, there we go. All right, so we're good. So we really didn't need to go up to 50, but we're good. All right, so we're finding that intersection point. Remember, when you find the intersection, what else do you have to have in there? Y equals 0. So you gotta remember that. So y equals 0. So we're gonna second calc the intersection. Number 5. So you remember you gotta go to the left. Enter to the right. Oh shoot. What's on my... Y'all see what I've done? I'm doing the intersection. What was I doing? I was doing the maximum. I wasn't paying attention. I was trying to get through this quick. Let me start over. Second, calculate intersect. Now I gotta move my cursor to the intersection point. Sorry. Woo. And then I went way too far. There we go. Close enough. Enter. So enter 3 times. So 5.88. So about, did they say to the nearest hundredth, which is 2 decimal places. So that 1 doesn't make that 8 go up. So 5.88 seconds. So that would be the first part. Okay. Anybody have questions? We good on that one? Okay, so second part, to the nearest tenth of a foot, what is the greatest height the ball achieves? Was that a maximum, a value, an intersection? What is that? It's a maximum. Is it the x or the y part of the maximum? It's the y part. Remember we talked about that a minute ago. It's the y part. We're talking about the height. There's a couple of things that y'all, or a couple of you had problems on that yesterday. Now do the maximum. So second, calculate max. And go to the left and right. So we're going to move on over. That's annoying. Yeah, I don't think it's their brakes. I think it's, anyway, so there's our, one of their belts, I believe.
Yep.
Alright, so here's your maximum. But which one are we looking at? The 2.5 or the 30.875? The 30.875. So that would be, it said to the nearest tenth, so 30.9, because that 7 makes that 8 go up to a 9. If they said how long did it take to reach its maximum? 2.5 seconds. Okay, so there's number 7. You good on that one, Shelby? Anybody else? So we're good? Okay, so pass these papers up to the front. So pass these up to the front, and if you were out yesterday, who was out? Kobe, you were out. Shelby, you came, but you came after school and did it. Was somebody else was out? Emma, were you out yet? Who was out yesterday? Christy, that's right. She's not here. Don't worry about doing this one. It won't count for or against you. All right, so now